So I want you guys to open to page 147. We're currently going to be looking at percents of a number. Percents of a number. So if we looked at this, we've kind of started this intro before. Our fraction is 23%. What we know about percents is that they're always over 100. So it just became 23 over 100. Now, an equivalent fraction, what does equivalent mean, Hannah? It means equal, exactly. These two are equal. Notice how, just similar to our ratio tables, what do we multiply 100 by to get to 200 miles?
2.
Times 2. So we do the very same thing to the top. What we do to the bottom, we do to the top. What we do to the top, we do to the bottom. So we multiply it. An equivalent fraction to 23 out of 100 is 46 out of 200. So I want you guys to complete the rest of this table. It should not take too long. So the reason we're doing this out of 200 is the question says, in a survey, 200 students chose their favorite snacks. And we're trying to figure out the percent of a fraction. So 15%, this is easy. It's always 15 over 100. This one's 17 over 100, 15 over 100, 18 over 100, and 12 over 100. And all of them go to 200. So all we're doing is multiplying by 2. I'm going to point at you, and you're going to tell me what the number is times 2. So I'm going to say this. Madison, cheese. 30, exactly. I want to see Melanie, veggies. Yes, 34, perfect. This one should be pretty easy. We did this. Matthew, what's cookies times 2? 30. Next one, Emerson, chips. 36. And lastly, Nathan, no snack. 24. Exactly. And then we just fill it out. So 30 out of 24, 34, 30, 36, and 24. And then what we check is we add them all together just to check that they equal 200. This step's a little bit pedantic if you know you did it right, but this is a good way to check. We add them all together. My suggestion for adding them together is to combine our numbers that make 10. So for example, 46, 34, when we combine them, if we move our 6 over, it's a whole thing. You get 40. You know what you're doing. Anyway, so we check that. So this is how we find a percent of a number. For example, I'm going to ask, what is 23% of 200? What is 23%? Rocco? No, 23% of 200. 23%. Anita? 46. 23% of 200 is 46. 23% of 100 is 23. So as such, I have a question for you. What is 12% of 300? What's 12% of 300, Romario? 36. Exactly, 36. When we're trying to find percents of a different number, for example, if it asked us to find 15% of 300, 15% of 300. What we would know exactly is we'd have 15 over 100 is equal to something, that x is a variable meaning something, over 300, because we're trying to find 15% of 300. When we're trying to find that, what we're doing is we're making equivalent fractions. Equivalent fractions. So, how do we go from 100 to 300? How do we go, Rafi? How do we go? How?
Because 100 goes into 300 times.
Perfect. It would be times 3. So, what we do to one, we do to the other. We multiply this one times 3. Lucy, what's 15 times 3? So, our x equals 45. Excellent. So this works all the time whenever we have a problem that can have easy multiplication. But what about when we have a harder one? So let's say we wanted to find 16% of 320. 16% of 320. So our initial percent, this way is the the longer, hard way. So we know our percent is 16 over 100. We need to make this equivalent with something over 320. Can I multiply from 100 to 320 easily? No, I can't do that. So what I do, the first thing I do is we do cross multiplication. Like we've done before, we do cross multiplication. So we're gonna get 100x. That's easy. 100 times x is 100x. If I had 100 times cats, how many cats would I have? 100. So whatever it is. Then I have 16 times 320. So 16 times 320, just using my calculator, I get 5120, right? Then we just have to do our division. We have to do our division. There's two ways that we can do, yet again, there's two ways that we can do this one. Notice they just keep splitting up because there's so many ways we can do math to get the same answer. We could either do our long division. What we're going to be doing is to get our x alone, we want to divide by 100. Because what's 100 divided by 100? Is 1. So it goes away and we would get x equals. So we have to do the same to both sides. We do the same to both sides. Now, there's two ways that we can do this. There's two ways we can do about it. We could put our dividend inside. And then we could do long division, which is quite frankly a little bit annoying. It's quite frankly a little bit annoying. So, quite frankly, long division can be a little bit annoying. But there we go. It's 51.2. But there's one other way that we can do it. When we have 5,120 over 100, in order to get our answer, we need it to be over 1. Remember what I said about moving our decimals? So, our decimal is here. If we want to get it over 1, we just move our decimal 2 places. So we do the same to the top. 2 places. So, look at how both of our answers give us 51.2. Both of our answers give us 51.2. So both ways, whether or not we did long division or just moved the decimal, we got the same answer of 51.2. Same answer of 51.2. And notice it looks super similar to 5,120 because we divided it by 100. We would do the same thing. If we were trying to find 18% of 317, we would still get 800 or 18 over 100 is equal to is equal to x over 317. All we do is our cross multiplication and then we solve. There's one more way we can do this. And we already learned how to do this, and this way is easier if you know what you're doing. So, this way is when we multiply using decimals. And we've done that before. In fact, that was the first lesson we learned, multiplying using decimals. So, what is 18 over 100 as a decimal? This is 18% is 18 over 100. What is 18 over 100 as a decimal, Hannah?
0.18.
Perfect. 0.18, right? If we multiply that by whatever number we were trying to get, if we multiply that by whatever number, then we get our answer. And here's how we do that. We already know 317, 18. We have this lined up all the way to the right. We always line them up to the right. We move our decimal over 2 places. So in the end, we're going to move it back 2 places. And then we simply do our math. So in this case, we would get that as our answer. We move our decimal back the 2 places we moved it over, and we get our answer to be 57.06. And just a quick calculator check confirms that that's our answer. So this is what we do when we can't easily multiply. This is what we do when we can't easily multiply. Now, I'm only teaching you this method because it will be coming up later. It's not going to be coming up yet. Most of the ones that we're going to have are going to be coming up easily. In fact, we could do things this way. Let's watch one more time. I want you guys to try this on your paper. I'm going to do one, and then you're going to try a separate one on your paper. We want to find 145% of 320. We want to find 145% of 320. Now, what's our first inclination? Is our number going to be bigger or smaller than 320? Is our number going to be bigger or smaller? Elsie? What do we think? Once we go over 100%, our number gets bigger. Now, what we get is 145 over 100. And we want to get that equal to something over 320. Now, we could do our difficult way of doing the decimal or the cross multiplication, or we could use our ratio tables again. So let's fill in our box of ratio tables, and I'll show you what I mean and why we're doing this. So we get 145 over 100, and we want to get something over 320. This is when we use something that can multiply into both. What is the number that is both a factor of 100 and a factor of 320 miles? 20, exactly. 20 is a great factor of both of them. How do we go from 100 to 20? What do? We divide by, Romario? Perfect. And how do we go from 20 to 320? 20 to 320, we multiply by what, Rocco? Not 64, that's a good guess, though. What do we multiply by? We multiply by 16. So we're going to do the exact same to the top. I want you guys to do this on your paper. We're going to do the exact same to the top. Rocco asked a good question. He said, why can't we make it like 120 instead? That's because when we're doing our ratio tables, and pretty much in all future math, when we're comparing numbers, when we're trying to change numbers, we can only do multiplication and division. Whenever we're changing a number into a different number, for ratio sakes, for proportional sakes, we can only do multiplication and division. So, Lucy, actually, you know what, Daniel, what is 145 divided by 5? We get 29. Now we got to multiply. And we multiply 29 times 16. Everybody did it on their paper. And we get 464. So let's look back. Remember what I said? We're trying to find 145%. Doesn't it make sense then that it's bigger? Doesn't it make sense then that our answer is bigger than our number? Yes. If you scored, exactly, Rocco brought this up. When the top is bigger than the bottom, we're going to have a number bigger than 1. Or 1 or bigger. Technically, yeah, 1, well, bigger than 1. When our top is smaller, that's when we have a number that starts with 0. Exactly. This is exactly how we do it. So now we've gone over 3 different methods. Actually, 4 different. Show you one more way. Here's a difficult one. I want you to find 0.25% of 58. 0.25% of 58. So the way that we do this first is we need to multiply. We're going to multiply because 58, we can't even ratio table that nicely. We can't even if we tried to use the ratio table, it wouldn't work. So we use our multiplication route. We make it into a decimal and then we multiply. What is 0.25 as a decimal? What is 0.25% as a decimal? Who can tell me? Matthew, not 0.25. What do we get? Madison, what is it? Yeah, let's look. We move it over twice, so we get 0.0025. Then we do our multiplication way times 58. The way that we do this, here's 58. We have our numbers. We always line them up all the way to the right. That's how we do multiplication. We line them up. Now, how many times do I have to move the decimal?
4.
I move it 1, 2, 3, 4. So at the end, I'm going to move it back 4 times. I want you guys to do this multiplication and then tell me the answer. So you guys did the multiplication on your page. What's the initial multiplication number you get before we move our decimals back? What's the initial one we get, Lucy? 1,450. You guys did the multiplication. I don't feel like doing it. But now what do we have to do, Nathan? Now what do we have to do?
We move the decimal 4 times to the left.
Exactly. Move it back. 1, 2, 3, 4. So what do we get as our ultimate answer? What is our ultimate answer, Rafi?
0.1400.
Perfect. We could also, exactly, 0.145 or 0.1450. Exactly. This is exactly how we do it. So there are 3 ways to find the percent of a given number. We can cross multiply, multiply with decimals, or do ratio tables. Let's look at this problem. We've got 6% of 95. Let's do this with cross multiplying. So whenever we have a percent, it's always over 100. So we've got 6 over 100. We want to make an equivalent fraction so we can solve the number, an equivalent fraction. We know our bottom is 95 because we're trying to find it of 95. But we don't know what our top is. Now, the first way we do it with cross multiplication is we do it like this, like our butterfly math. So we solve it. We get 100 times x is just 100x. And then 6 times 95, if we did the math, we'd get 570. Now we need to isolate the variable. Isolate means to get alone. Think about if you're in isolation. If this is multiplication, what's the opposite of multiplication? Division. So we just divide. 100 over 100 is 1. It goes away. We have this one, 100. The 2 ways we can solve it now are to do our long division, which can take a little bit of time, or we can move our decimal. Let's do long division. 100 does not go in here, does not go in here. It goes in 5 times here. That's 500. We subtract, we get 70. Here's our decimal. We bring down another 0. How many times does 100 go into 700? 7 times, and it's easy. That's our answer. Again, we could do this by moving decimals. So whenever we get something over 1, that means it's its answer. We don't need to write over 1. That's always how it is. So we move our decimal 1, 2. So now it's 1.0. So we do the same to our top. Notice now we get 5.7. Same answer both times. Yeah, exactly. So the bottom would just be 1. We get 5.7 over 1. And anything over 1 is just itself. Now there's a second way to do it. This one's multiplying with decimals. So we have 6%. What is 6% as a decimal?
No, you do.
What's 6% as a decimal? So to find the decimal, we go for the percentage point, the decimal point, and we move it over twice. So we get 0.06 is our decimal. We move it over twice from the percentage point. And we remember that because here's a percent, here's a percent. 1, 2. We move it over twice. Then all we do is 0.06 times that number that we're trying to get, 95, times 95. Now the easiest way to do that, we have to set up our multiplication. We have 95 on the top and then 0.06 on the bottom. Whenever we're multiplying, even with decimals, we always line them up on the far right side. When we multiply with decimals, we need to move our decimals over, but we will move our decimals back the same amount of places. So then we need to solve 6 times 5, we get 30.
Dark chocolate.
6 times 9, we get 54. We add the 3, we get 57. Notice when we move our decimals back over, we again get 5.7. Works out really well. Same thing over here, 5.7, 5.7. Lastly, there's ratio tables. Now, ratio tables don't always work for every problem. They are the easiest way, but because they don't always work, we need to know the 2 other ways. So here, we had 6 out of 100, and we wanted to find something out of 95. We can't easily get from 100 to 95. In fact, we can't easily even get to something in the middle that would go down. So if we gave it a different example, let's give it a different example. Let's find out how much Let's find out how much 4 out of 100 is out of 80. We think of something they have in common. Something they both have in common happens to be their greatest common factor, 20. How do we get from 100 down to 20? We divide by?
The world's biggest gummy worm.
5. Excellent, Jaden. How do we get from 20 to 80?
Hubba bubba.
Multiply
Hubba
times.
bubba. You call them.
Perfect. Multiply times 4. So we do the same at the top and at the bottom. I'm actually going to change my answer because I was dumb. We're going to make this a 5. What's 5 divided by 5, Jaden? 1. What's 1 times 4, Jaden? 4. So we find out that the answer would be 4 out of 80 people. 4 is 5% of 80. 5% of 80 is 4. As we know, 6% of 95 is 5.7. So those are the 3 ways that we can go about solving, finding a percentage of a number.